Pranam children, this is in continuation with the previous class where we learnt how to find where does this 4 upon 3 lie, between which two integers this number lie, between which two integers this 6 upon 3 lie, between which two integers this 8 upon 3 lie. Like when we write 4 upon 3 as 3, 1 upon 3, it means this number will lie between 3 and the next number 4. Similarly, this 8 upon 3 will lie between 2 and the next number 3. And this 2 upon 3, we learned that this is less than 1, so it will be lying between 0 and 1. As the denominator here is 3, I am going to divide 0 and 1, 1 and 2, 2 and 3, 3 and 4 into 3 equal parts. Like this is 1 upon 3, this is 2 upon 3. Then comes 3 upon 3, which is equal to 1. Then 4 upon 3, 5 upon 3, 6 upon 3, that is 2. 7 upon 3, 8 upon 3, 9 upon 3, that is 3. Similarly, we'll keep on moving like 10 upon 3, 11 upon 3, and next is going to be 12 upon 3 as 4. Now I need to plot this 2 upon 3 here. So this place represents 2 upon 3. Next is 4 upon 3. This position means 4 upon 3. 6 upon 3 is same as 2. So here lies 2 or 6 upon 3. Next is 8 upon 3. That lies between 2 and 3. So this is 8 upon 3. Now this was the example of a positive rational number. What happens if the number is negative? Suppose the numbers I need to plot or I need to represent on the number line are minus 3 upon 7, minus 5 upon 7, minus 16 upon 7, minus 2 upon 7. Now here, because the denominator is denominator is 7, and here again numerator is smaller. So this number will lie between 0 and minus 1, and minus 16 upon 7 will lie between minus 2 and minus 3. And this minus 5 upon 7 is again lie between minus 0 and minus 1. So what I did is I drew a number line. I plot the points 0, minus 1, minus 2, minus 3. Then I divided 0 and minus 1 into 7 equal parts. Then minus 1 and minus 2 into again 7 equal parts. Then minus 2 and minus 3 again in 7 equal parts. So the third place, 1 upon 7, minus 1 upon 7, minus 2 upon 7, this shows this place is minus 3 upon 7. Next is minus 4 upon 7. The next to it is minus 5 upon 7. Next comes minus 16 upon 7. Because this number I told you lie between minus 2 and minus 3, I'll directly divide minus 2 and minus 3 into 7 equal parts. And then as this place was minus 14 upon 7, this will be minus 15 upon 7, and this will be minus 16 upon 7. So doing this way, you can plot any rational number on the number line. So using this, you can easily complete exercise 1.2 of your book. Just keep in mind few points. Where does these type of numbers lie? Where this type of numbers lie between 0 and 1. Similarly here, the number lies between 0 and minus 1. Whenever the number is of this kind, the number will lie between, it will be after 1. Same here, it will be after minus 1. And whatever is the denominator, in the same number of parts, we have to divide the consecutive integers. Here, the denominator was 3, so I divided 0 and 1 into 3 equal parts, 1 and 2 into 3 equal parts, 2 and 3 into 3 equal parts, and same way I kept on going. Here, because the denominator was 7, I need to divide, and the number was negative. I need to divide 0 and minus 1 into 7 equal parts. Similarly, minus 1 and minus 2 into 7 equal parts. Minus 2 and minus 3 into 7 equal parts. 7 parts means I have to put 6 more points in between. This is the first part. This is the first part, second part, third part, fourth part, fifth part, sixth part, and seventh part. So take care you don't make mistakes. Now next is how to find rational numbers between two rational numbers. For example, find 5 rational numbers between minus 2 and 0. These type of questions we have already done in class 7. Where what we used to do is, suppose I have to find 5 rational numbers. I multiplied both the numbers minus 2 and 0 by 6 upon 6, and I got minus 12 upon 6 and 0 upon 6. So all the numbers lying between minus 12 upon 6 and 0 upon 6, like minus 11 upon 6, minus 10 upon 6, minus 9 upon 6, minus 8 upon 6, minus 7 upon 6, minus 6 upon 6. Same way we'll continue till we reach minus 1 upon 6. Any number we can choose out of these. Any 5 numbers can be the answer of the given question. But here we do not know the midpoint. Now the question arises, if I want to find the midpoint between these numbers, like if I want to find the midpoint between 3 upon 5 and 5 upon 9, how should I go? To find the midpoint between 3 upon 5 and 5 upon 9, I need to find the average of 3 upon 5 and 5 upon 9. Means I am going to multiply half to the sum of the given numbers. Or you can say I'll add the numbers and divide it by 2. When I added the number, I got half, and I took the LCM. I got 45, 15 plus 25 in the numerator, and then I got 40 upon 2 into 45, that is 20 upon 45, and I cancel 40 with 2, I get 20 upon 45. So this number 20 upon 45 is going to be the midpoint of 3 upon 5 and 5 upon 9. Similarly, I can find infinite number of rational numbers between two given rational numbers. So next is I am going to find the number between 3 upon 5 and 20 upon 45. I'll again add them up and divide it by 2, or you can say multiplying by half the sum of the two given numbers. This is also same as the average of the two numbers. When I did this, I got 1 upon 2. I took the LCM as 45 and divided this by 5. I got 9. 9 is 27 plus 20. So I got 47 upon 90. So 47 upon 90 is the midpoint of 3 upon 5 and 20 upon 45. Using this method, you can find infinite number of rational numbers between any two given rational numbers. So using both the methods, you can complete your exercise 1.2 easily. Thank you, children.